All right, welcome to the first of our seminars. Please note these meetings will be recorded and posted to YouTube so people can review it if they miss it. This first meeting's fairly straightforward. What we want to do is introduce you to your advisors for the projects and also meet our students and find out what they intend to be working on. So we'll have a little bit of an introductory session, but from the next session on, we start off with a short presentation on something that's of interest, just to sort of trigger some discussion. These may change as we go along, depending on the interest of the students. We can put together things that actually suit what the current cohort are working on if need be. But we do have things ready to go, and we'll use them as a bit of a introduction to other areas which aren't necessarily covered directly in the course. Just start with the introduction to the advisors with us at the moment. There's myself, Rash, Yiffy, Hannes, Valerie, David. Nazanin may come in every now and again, but she's a little tied up with other things. And we all have a specific area that we've got expertise in. So it's a good idea to make a note of the names and what area people are in. So that if you have specific questions, it's good to let or send that directly to the person best to answer it. And I'll talk about that in a sec. So I'll kick off. My name's Ian Murray. I'm a professor in electrical and computer engineering at Curtin University, of course. My area of expertise is general networking, IoT, industrial IoT, assistive technology, sensors, and pretty much anything you would do in the IoT area except the big data. I don't do that bit. We have someone who Sebastian, you want to give a quick rundown? We'll just go through the list of names as they appear here.
Sure. Hi, everyone. I'm Siavash. I'm a lecturer here at Curtin. My area of expertise is in small electronics, embedded systems, and smart devices. And I also do research in assistive technology, so building technology that helps people with disabilities. And I use a lot of IMUs and inertial measurement units, so a lot of human movement capture in my research. So if you had any questions from that low-level digital design, I'll be the person to go to.
Okay, Yiffy, please.
Okay, hello everyone, I'm Yifei. I'm also a lecturer at the Curtin University. My background is wireless communication and reinforcement learning, and my past research was about the layer 2 microprotocols. So in English, basically makes the Wi-Fi more faster. And I also have some experience with all popular programming language like C#, Java, and Python. That's basically it.
Okay, thank you, Yiffy. Hannes?
Yeah, good morning or evening or afternoon, depending where you are in the world. I'm Hannes, I'm from computing. My background is in logic and artificial intelligence. Not so much the machine learning part, but algorithms, algorithm design, complexity, and basically playing with hard problems. So if you've got something like that, I'd be quite interested to play with it. I also had been doing databases. So if you've got storage questions, I may be able to help you with those. I'm less of a hardcore programmer. If you've got programming specific questions, there's probably better people than me to ask, to be quite honest.
Thanks, Hannes. And that would be Valerie. You would ask about the programming issues. She's unfortunately teaching other things this morning, but she will be joining us for a few of these, and she's giving a big data talk in one of these sessions towards the end of the course anyway. But Valerie is definitely our Python expert, our big data expert, data science, those sort of areas, predictive analytics. So if you've got any questions on that, best directed to her. I'm not sure if David's here this morning. He was tied up, but he will be with us from next fortnight on. David, you there? No, David's not there. David is a GIS person, Geographical Information Systems person, but a software engineer by trade. So when we start to look at including location in your IoT designs, and how we work with mapping, finding where things are, mapping into other databases to do with spatial information. David is the guy to talk to. All right, so that's the bulk of us. We do have other expertise we can pull in whenever we need to, from power systems, physics, maths, stats, all kinds of areas. So if you're unsure, just send an email to me, or bring it up during these sessions. You should have noticed there's an IoT capstone email address that goes to all of us involved in the course. It helps if you put the name of the person that you want to get the answer from in the subject line, just to help us get to it. We do get rather busy. We all have other real jobs, teaching classes, like poor old Vel and her 800 students in a Python class that she's got. So we can miss things. If you don't hear from us in a couple of days, please email again just to chase us up, just to bring it back to the top of the list. Okay, some ground rules for the seminars. Be polite and respectful. That's just normal. We just want to help each other out. The purpose of these seminars is to find out what you're up to ask any questions you have, but more importantly, to find out, for you to find out what other students are working on and to form some teams so you can actually help each other out in your design. Now, this is really useful, particularly when you're working in an area and you find someone is working on a similar type topic, but they have a different background to you. So we get people from engineering backgrounds, yes, of course, because it's mostly an engineering course, from computing backgrounds, but we also get people from very, very different fields of employment. We've had vets, doctors, farmers, lots of different people. And they may not be that wonderful at the technical side, but they have an insight into the application areas. And that can really help you if you're a technical person, excuse me, or if you're not a technical person, but you do understand the business area or the application area, you can get help from some of the more technical people. Okay, off track there, but we'll continue on. If you'd like to speak, just to keep things neat and tidy, it's fine with only a couple of you in it at the moment. But if you could use the raise hand function in the chat or type a question in the chat panel. We'd also like you to mute your microphone when you're not speaking. Video is not necessary unless you want to, but it is nice to see who we're actually talking to. So it's up to you if you do. So what we'd like to do now is we'll run around, and I can't see who's on. So Savash, would you mind calling the names out? We'd like you to introduce yourself, so who you are, whereabouts in the world you are, because we really have absolutely no idea where you are. And what your idea is, or if you're unsure, now's a great time to start talking about where your interests lie, see if we can help point you in the right direction for a development, see if it's going to be feasible, sort of explain what levels we expect people to get to at the end, and how we can actually help you get there. So, Savash, if you could just run around the table of how many students we've only got a couple, Phil?
Sure. So I can see two people with us at the moment. So I'll start with Robin, if you don't mind introducing yourself and tell us a bit about what sort of project you're interested in doing.
Hi. So my name's Robin. I live in the Milwaukee area, which is just north of Chicago, for those of you not from the States. And the project I'm thinking about doing is basically like a houseplant monitoring system where you can have a device. It speaks wirelessly to like a Raspberry Pi, and then you can have it with a display or not, and then optionally, based on the water levels, turn on the water for the plant if need be.
Okay, that's good. One of the things you might want to consider adding in is some of the other environmental sensing. So these are indoor plants?
Yeah, I in the description I put up, I also mentioned light levels, fertilizer levels, and then temperature.
Yep. And humidity is also a handy one to keep in mind there too.
Okay.
If you're looking at cropping plants, like say growing your tomatoes in a greenhouse, also consider looking at the CO2 levels, airflow. And if you really get interested, you can start doing some particle sensing and look for one of the projects we've actually got with the agriculture researchers, looking for spores which can carry contaminants and diseases to the plants. So we can help you out with that one with what we've been doing with the agriculture department here. But interesting. Yep, all good.
Thank you, Robin. And we have another person with the Bentley P2.1 ID. Would you mind introducing
apologies,
yourself?
guys. I'm dialing in from my work system here.
Okay, no worries.
My name's Alistair Power. I'm a solutions architect around the corner from you guys at Horizon Power. So I already do quite a bit of work with IT communications, but generally like anything enterprise level. Got a couple of project management skills, and I do a lot of translating business requirements into technical solutions. So it's something I'm pretty good at. Where I fall over is a little bit rusty on the programming skills. Haven't done that for quite a few years. So and some of the hands-on of the hardware. My capstone idea, it's big around some of the issues we've had with, say, I don't know if you guys have heard of the Shell Prelude incident, where Shell's lost $4.5 billion because of unsafe isolations. So what I want to do is put an IT tracking system on their liquid and gas valves, so it can track the change of state and transmit that to some type of centralized application, so the guys that are managing that plant can get an extra bit of automation that tells it, all right, it's open or closed, and that can tell them whether they can proceed or not.
All right, yeah, I remember we've had a bit of a chat about this, haven't we?
Yes, we have.
We have indeed, yeah. Sebastian should be interested in this because we're talking about using methods of physically monitoring the physical position of the valves.
I think I've considered trying to do a reed switch with this, but never could quite work it out. And I think you suggested it was an accelerometer of some kind as well.
Yep.
Yeah.
So if we look at the accelerometer, we can pick the gravity location, right, and find out which direction the switch is actually facing. And it's a much more reliable way, and we can tell if, for example, if you've got a round valve that they haven't turned off altogether, you can actually tell that from the IMU. So a valve or a switch or a whatever they're called, toggle is not fully off. You'd be able to actually tell with the IMU, gather all this data, match it to the plan that you have for the plant isolation.
Yeah.
And then if there's anything that doesn't match what is in the plan, you'll get notified immediately.
Yeah, that's the whole idea. The whole idea is we can put this in, and if anything is slightly open, they'll roll back rather than risk a hydrocarbon leak and have their stuff blow up, which is the idea.
Yeah. So that's a really nice one. And unfortunately, we can't help you here, Robin, but Alistair, if you want to ever need to come across the road and have a look at what we've got, or maybe borrow some gear, just give us a yell. We should be able to manage that.
Look, I definitely will, guys. Absolutely.
Yeah. Just out of interest, we're trying to put in an industrial IoT lab based around probably Honeywell equipment and Rockwell equipment. If your company is interested in having a look at that or joining in with it, it's hopefully sponsored by Alcoa and a few others to actually get the plant in. But it might be a good place to do training, that sort of thing.
No, you mean Horizon Power or the other company I'm working with on this other thing?
Well, either anyone who's interested in the control.
Yeah, I'll come check it out.
Yep. We haven't got it yet. We're still working on it, but we've got plans. In fact, Yuffie, I'll send your sketch through to Alistair.
Sorry, I was talking to a student, so I was lost a little.
I'll send your industrial IoT lab plan through to Alistair.
Okay.
Yep. Okay, so that's our students, I believe. Okay, so in future, the purpose of these meetings is to give you a chance to ask questions. That's really probably the greatest value of the IoT Capstone course, is that you will have access to people who do this for a living, basically, during those times. And of course, you can email. So we really do like people to join in. We don't want to spend an hour talking at people. We'd really like to see it as a discussion. And that really is the value. Get discussions going on what you're interested in, what you want to do, how we can approach it. And quite often students will come up with really great ideas that are out of left field and we wouldn't think of on how to solve particular problems. So ask questions, talk a lot, and meet your teammates. And that really is good value. Yeah, we'll talk about that later. We want you to propose an idea, but don't be limited. Try and be really ambitious and out there with what you're trying to do. What we're looking for as far as the requirements of the course are, is the process you go through to design, plan, and then test your device. If you don't get a physical prototype working, that's not necessarily a problem. It's very nice if you do. But in some cases, people want to test their business model and see if there's going to be a way of making something they have commercial. Is there a way of building it, but they may not actually build it. So be really creative and ambitious in what you're planning to do. Think about the requirements. What equipment are you going to need? Is it going to be available? Are you going to be able to build or use the parts that you need? Is it something we need to work out a way of simulating rather than simulating or emulating rather than actually getting a device? An example of this is where you want to, say, collect human data. That can be a little tricky. If you're doing it officially, it requires all kinds of ethics clearances and documentation and process to go through, doesn't it, Savash? Savash is our ethics expert. So it may not be timely or worthwhile to do that. So what we quite often do is we take a little microcontroller like an Arduino Nano, and we use it to produce pseudodata. Right? So we create random numbers from this device, which would match the sensor that you're using. Okay, and in that way, you can test the rest of your process without actually having to take blood samples or go into a nuclear reactor or things that we can't easily do in practice. So if it comes to that, we can actually help you build a emulation of a sensor or of data to help you build your prototype and test whether it's going to be functional or not. Yep, so we'd like you to start a discussion on the discussion boards. Yiffy is going to be monitoring very, very closely our discussion boards, aren't you, Yiffy? Yes, he says.
Yes.
Yes. So if there's anything that comes up there, he will either answer it because he's very capable or get one of us to respond. So those discussion boards will be monitored, and if you put anything up there, hopefully get answered very quickly. For next fortnight, it'd be great if you could make a list of questions either for your teammates or for the advisors that you're forming within the edX community and bring them along so that we've got something to talk about. It's a little hard to get started because you don't know anyone, you're not sure the processes, but it's meant to be a very open discussion. And that's really all we wanted to cover this particular one, but we're here for a while. So if you want to start talking about your design, have any questions, now is a good time to do it. So I'll stop the PowerPoint, but we'll keep recording. One thing I will mention is if we had to, well, we don't necessarily have to, but if there aren't enough people who want to attend in the morning, would you guys be able to make our evening session, which is 8 p.m. our time? Just trying to think what that would be. Horrible time in the US for mornings. So maybe not. But just something to think about. If we did, Robert, and we don't have any other US North American students, what we could do is if you listen to the recordings that we make of the 8 p.m. plus 8, 12, sort of 10
I should
o'clock.
be able to make the 7 a.m. one too.
Okay, but if not, I'm happy to have a chat with you whenever you need to. I'll give you my Skype ID, and we can talk separately if need be. But if you can make the other one, that'd be great. But we will definitely run again next fortnight in our morning, because it might be that a lot of students just didn't catch it in time.
Yeah, I thought I saw there's a couple people in the discussion that were looking for this time.
Yep. Oh, we don't mind. It's, if we get a few in, half a dozen, that'd be great, and we'll keep going with it.
Hey,
Okay.
Ian, it's Al here. Just on that, the 8 to 9, it might be difficult depending on what my 12-month-old wants to do. So he's usually when he's a bit high maintenance. So my preference is the morning, but otherwise I can work it out.
Okay, well, the offer stands for you too. If we do cancel the morning one, more than happy for Sebastian and I or anyone else that you need to talk to you via Skype separately, and you can watch the recording for the other team members.
Yeah.
Okay, you have any questions? Anything you'd like to talk about?
I might just give a quick suggestion to you, Robin, because if you're considering Raspberry Pi, if you wanted to go to a more interesting route, I would recommend looking into these M5 stack boards that I recently found. I'm just going to put the link for it in the chat. These are based on ESP32s. And lots of IoT solutions have started going the route of an ESP32 because it's a dedicated microcontroller that has a Wi-Fi and Bluetooth module built in. This M5 stack that I've shared with you, this is something I recently found. It's a modular microcontroller that has M5, that has the ESP32 and a couple of other things in there. And then it allows you to program it online with a visual programmer or Python, or you can also use Arduino's IDE to program it. It's pretty nice. It has a couple of IoT dedicated modules. It has an AWS module that I've seen.
Stepper motor controllers.
Yeah, it has lots of sensors that you can plug in. What I found interesting about it is the modular design. And it has a screen, so you can also design the interface for it. So if you wanted it to be just a planned controller, you can just put some icons, some toggle switches there, where you can kind of swap between a couple of screens. But just something that might be worth looking into.
Oh, this looks really interesting.
Hmm.
My experience is with Nordic, so they do a lot of stuff with AWS too. So, but I see the ESP32 come up in discussions a lot on their forums. So,
especially because it's micro. So I teach a lot of embedded system units here in our university, and when you have limited resources in an embedded system context, you usually are forced to be a bit more innovative in how you're using these resources. And these modular designs are pretty interesting, I think.
Yeah, one of the sessions we go into later on is about the commercialization side and how we start looking at producing something for the consumer. And reducing cost even on processors by a few cents makes a huge difference to the end cost. I once saw something that Apple put out, and they said if they added a single $1 component to their laptops, it would actually make around $100 difference to the selling price of their device by the time they've designed it in, built the system to actually place that on the board or on the case. So I think that was a bit extreme, but it does impact the cost dramatically. And if you're looking at a lot of IoT systems that require battery, solar, or other locally generated power, reducing the CPU power reduces the energy cost dramatically, which means you don't have to have as big a solar cell, and it just sort of triggers all the way through in reducing the cost. And of course, IoT stuff, you really do want it low cost in most instances. The exception being industrial control, where it's not as important, but it is important, and medical systems, which nobody seems to care. Okay. Anything else that anyone wants to talk about? We're here.
Yeah, I think I need to digest what my overall plan is a bit more and look at the accelerometer approach and possibly some business research funding, and hopefully I'll have something a bit more concrete to ask you guys about next week when I hopefully get into a few challenges.
Yeah. What might be handy is, have we got any of the older IMUs floating around?
Yeah.
Yeah, we can possibly lend you one of the existing prepackaged IMUs. These are not something you would use in your design because they're expensive, between $100 and $400 each. But the chipset that's inside them, how much are they now? $9, $8?
Yeah, they're very cheap,
As a
especially the
one-off.
older ones. Yeah.
So if you're actually building a system, the price would fall to $1 or $2 each. But if you borrow one of these prepackaged IMUs, you can use that to gather the data and actually look to see what you're getting and see how you're going to process it.
That would be really good.
Well, just give us a yell when you can and can come over and we'll get one out for you.
All right, I'll come over and see you guys next week.
Sure. One more thing I would mention, mostly for the recording. As Ian mentioned, we have a lot of people from a lot of different backgrounds and different skills, even people outside engineering in the course. So don't worry if you don't have that much of an experience with the technical side of things, because your project could end up being you defining the requirements and the design component of the IoT system rather than the low-level electrical engineering design of it. And that's still a very viable project. And I think just something to keep in mind.
Yeah. As I said, we've had some really interesting projects completed by non-technical people. One of my favorites, here we go, the horse. A vet looking at remote monitoring of the health of horses. And one of the things that they do is they check the color of the horse's mucus, and that gives indications onto the health of the horse. So he developed a system to identify the color of horse snot as part of its system. But it was a non-technical person, but nobody would have picked that up without being the vet. And that's why it was really interesting to see what he was looking for and how that could then be implemented from his industrial knowledge or his area of expertise.
Did you guys actually end up building anything for that?
Yeah, he built some stuff, yeah.
Can you put me in contact with him? Because I'm about to move to a stud and breed farm. So just a bit curious about it.
Yeah, well, I can see if we can dig it up, and I'll send him an email, see if he's willing to talk.
All right.
Yeah. Nobody's commented about my little PC in the background.
Little.
Yeah, just got it.
Looks like an average gaming PC, Ian.
Yeah, yeah. Well, as I said, we're just going to use it to play Minesweeper.
Yeah.
Well, at least go for Fortnite or something.
No, I'm not sure it could handle that. Yeah, as soon as we can find somewhere we can actually plug it in. 20 kilowatts per rack. All right, well, if there's nothing else, I'll stop the recording. And thank you all for turning up.
Awesome. Thanks very much, guys.